So the goals for the tuning protocol today is to look over Ms. Wang's HAT task. Remember the three criteria are student engagement, cognitive development, and alignment to Common Core standards. So Ms. Wang?
Okay, so this is the end of the unit HAT task. In the unit, we looked a lot at confidence intervals and calculating based off of observed proportions and/or sample means and standard deviations, how to calculate the confidence interval of something happening. And so that would be a good idea to introduce them to Simpson's paradox, which is basically when you put data all together, it says one thing, but then when you look at it separately, it tells you something different. And so we went through a little activity the day before so that they were familiar with it, and then the HAT task was just to apply that to the new situation.
Okay. Let's take a look at the HAT task and see if we have any clarifying questions for Ms. Wang. 30 seconds. Okay. Any questions for Ms. Wang? Clarifying questions?
Part D, the phenomenon, is that, but yeah, I don't see it anywhere else here. Is this something you discussed?
So the phenomenon is just a Simpson's paradox.
The Simpsons paradox?
Yeah.
Okay.
So they knew that that's what the phenomenon was there.
Yeah, and based off of letter C, if they did letter C correctly, they should have analyzed and said that when you look at the data separately, it says that David Justice has a better average, but then when you look at it as an aggregate, Derek Jr. has a better average, and so that was a question, so I can explain it again.
And what is the grade level for this? Like 11, 12?
There's a little bit of everyone in there. Mostly 11 and 12. There's a couple of sophomores and freshmen.
And this was a HAT task given at the end of the unit?
Yes.
What was the unit?
Confidence intervals?
Do we all have the same one?
Yes.
Same
Yes.
students?
Okay, so now we'll take about 5 or 6 minutes. We're going to analyze the work and complete the template. Let's just go around the circle here and give Ms. Wang some strengths and some questions or feedback on next implementations for this HAT task.
Well, I'll start. I said I think this HAT task was perfectly scaffolded, and I think that she provided them with all of the information that they needed, and especially for number 2, she gave them how the probability needs to be set up, because a lot of our students tend to forget and their working memory is just not there. So I really liked that part, and I liked how usually like our HAT tasks are just broken into sections, how she numbered each question and everywhere that they needed to hit. I like the table because a lot of our students are also visual learners, so the tables will help them navigate and then pull out the information. The only suggestion that I had was because I'm looking at what is it, 2D. I don't think she explained the phenomenon or the reasoning for the phenomenon well. So maybe in using phenomenon, I don't know if you did, but explicitly teach that word and how it pertains to the role, and just make sure that they remember that specifically for the hot task that you're going to be given that day.
I also liked how it was scaffolded beautifully. It really takes them from one step to the next. I really liked this extension question at the end, and I think what I was thinking in my head is, was thinking of my students, they might have trouble finishing this whole thing, but I really think they get the entire goal of the hot task by question 2. So this is kind of like a nice extension for, I guess, students who get there. That's just how I was thinking. I also had the same comment as Ms. Simmons, maybe just explain the type of phenomenon it was, like why do these stats look differently when they're added together as opposed to looking at them separately, because she did struggle actually explaining that, and that was really the only flaw of her work here. And the only other suggestion I had, just to kind of promote student engagement, is maybe changing this to, because so many of our kids are like basketball crazy, that like that could be that could be something. Maybe changing it to a basketball problem, because you can really do anything with these type of stats. Sports is like, there's so many statistics that go into sports. Or even just using a more current player than David Justice. Because, I mean, everyone knows Derek Jeter, but, I mean, those are the only two things. I thought it was a great task.
Yeah, I agree, basically what you guys said. I like the scaffolding. I agree with what you said also, that the scholar didn't seem to really even address why it's a paradox. Maybe if you reword the question, maybe could lead them more towards it. What else? Oh, I would like to see more consistent rounding. Like sometimes they round it to 5, 7 decimal places, sometimes 2. By the way, just as a baseball fan, batting average is also rounded to 3 decimals. Places.
I didn't think you wanted to be that picky with it, but yeah.
Are you a baseball fan? Oh, okay. And I also thought what you said is also, I agree with, is that these kids were like just being born at these years. So to them, that's ancient history. That you missed an opportunity to make it really relevant to them today would be basketball players. Like they're always talking about LeBron versus Durant.
Annoyingly talking about
that would really capture their interest.
Yeah.
So I think a lot of them would not, like you said, not know David Justice.
Oh, and there was one other thing I had. Maybe for students some of your higher level students that don't meet this formula in, maybe you can add that in as a scaffold as opposed to giving it to everyone and saying, you know.
Also, misses aren't technically required here. So I think that may have been too much information. You could just calculate batting average on hits and add bats. I don't know, I didn't see the other scholars' results.
So I'm not going to repeat what everybody else said. I just have 2 things. One of the strengths that I liked was the fact that the questions were different. You didn't ask the same type of question over and over again, which then hits on many different kind of learners and levels of thinking. It wasn't all what is or how. It was a lot of determine, if, explain, based on this. So you're hitting on the, the high levels of knowledge, or 4 levels of knowledge actually. You're going towards the high section there, and that's great. Something that I noticed, and it's just housekeeping structure, missing equal signs, even though it's something simple, it's something that you may want to go back and say, what was the difference between, if you look at Derek Jeter hits 96 times 184 plus 12, and this student meant to put an equal sign, I believe, there. But as right here it says hits. Yeah. So it looks like multiplication at that point. So just for accuracy, even though an equal sign for them it doesn't mean much, but in the scope of mathematic understanding it does. Or not so much understanding on their part, but the person who's grading what they're doing. And also, I have a suggestion when it comes to an instructional method. Something that I just read in the book that we were, the chapter 1 from the course 6. One of the strategies there that goes excellent with the hot task is there is a reading for meaning section in the book in chapter 1, and there's a section there where they show a protocol on how to teach kids to look for the evidence to support an argument. And I don't know if you guys read it, but it was about with the word problem. You give them a bunch of statements prior to the word problem, statements that are false and true, which they label. And then as they read the problem, they have to justify from things that they're reading in the problem, whether those why the statements were false or true. So that's a nice way to introduce hack tasks, especially if we're looking for those evidence of for the standards of gathering evidence to support your argument. Because I think we assume that students know what an evidence is, what is an evidence that supports a claim. And so I think that doing this, especially for question D, when you're talking about the phenomenon, it will go really well because they will know that they need to justify this phenomenon from data. So that was on my end. That's your turn.
Okay, so I guess just to, there's a, I forget who the first mathematician was, but like I just used this data because he had like found that it just happened with this set of data that it works out that way.
Mm-hmm.
And so that's why I just use this data, but if I stick in. And then I really appreciated the feedback on the phenomenon one. Based on like their responses, it was very vague, and one of the students asked me what a phenomenon meant. And so, like I told them in class, it's just like, why does like what happens in part C happen? But I think like if I were to expand and reword on it, it would bring out more of their thinking and verbalization on that. As other than that, the parentheses, the equal sign, I like didn't even think about it because I told them after like a little bit into the task that they had to show how they got their numbers and to not just throw numbers in. And so I just assumed she like went back and put
That's why she put it.
Yeah, but I completely get what it was.
Okay. Any questions? Any other comments that you would like to add in terms of implementations or instructional methods that Ms. Wayne can use in her class for the next task, or when she gives this task again next year, other than the suggestions already given?
I actually meant to say, this was probably geared towards that specific phenomenon that you were looking at, and I assumed in my head, just forgot to say that this data worked with that, but.
All right.
Good.
Thank you very much, guys. May I please, I would like to collect your templates. I don't have to collect the task itself, but